Okay, so the last thing to talk about in more mathematics, at least the last thing we're going to talk about, because it's a huge topic, is equation arrays. So let's come back to my screen. Often we want to align related equations together. In fact, do align related equations together. Or if we've got a long equation, we need to align it properly. Or if we've got a multi-line derivation, we need to align the parts of the derivation so it's most easy to see what's going on. Okay, the align mathematics equation does this. It allows many columns, and each column is alternately right justified, left justified, right justified, left justified, right justified, etc. Usually we only use 2 columns. But if, for example, we use the align environment like that, that would be 3 lines, 4 columns. The first and the third column would be right justified, and the second and the fourth would be left justified. Got that somewhere. Here we are. So here is one example where we want to align an equation. It's 3 equations. It's all talking about the one thing. It's the flow of a fluid. It's talking about the horizontal velocity, the vertical velocity, and the pressure of that one flow. So we want all those equations together and aligned. The align environment does it. Here it is. And you can see we've just put the ampersand, the align character, to the left of the equal sign in every equation. That's a common place to put it. The other one would be to the left of each equation. So by default, you should align to the left information. Now, the basic aligning environment will number every equation, which means we can label every equation and refer to each of those equations individually by their individual label. If the 3 equations are always going to be referred to together, so that we want only one label like this, then we can do a similar sort of align, but in the line that we don't want to label, we put \no number. That's the last line. First line's also got a \no number. The second line does not have a \no number, so it gets the number, and we label it so that we can refer to it. Now, one of the things about that is you saw I put the aligning character ampersand to the left of the equal sign. That is generally what you need to do. Do not put a relation to the left of the aligning character, because LaTeX screws up the spacing. It's not LaTeX, it's one of the people who wrote the ANS math package. Okay, organize your maths so relations are at the start of a left aligned cell. Okay, no number stops the numbering. If you use the star form of the align, then you get there's no numbering at all, as in this derivation. Okay. So here we are in the maths, no number, and it's because we used the star form, and that meant we didn't have to put \no number on every line. And you can see it's beautifully aligned there. The explanation is offset from the mathematics by the quad space. So here we have the first line, the mathematics, then \quad, and then within \text is the words by the distributed letter. The next line, \quad, text by excluded middle, and so on. So that's the basic align. Another useful facility that AMS Math gives, and that is the subequations environment. What that does is, as you can see here, it generates the labels which are a base number followed by the letter A, B, C, etc. in that sequence. And it applies to these three equations because I've gone begin subequations before the start of this math, and then subequations after the end of the math. So each equation gets a number. That's good, 5A, 5B, and 5C. So you can label them, and you can refer to them individually, or you can refer to the collective. The 35, because you can label the collective. So after begin subequations, just put a label, and then that gives you the collective one. I've got to say, this is a nice facility for all sorts of reasons. One mistake I made was I once had a longish 4-line equation, and I organised the lines so that different physical processes were represented by the mass on each line. So I will discuss those physical processes by referring to in the text, the first line, second line, third line, fourth line. Unfortunately, what happened when it went to the layout editor is the layout editor said, oh, I can save space in the journal by putting those 4 lines into 2, which was sort of mathematically fine, but it then just did not match the discussion in the text. So my text was, for example, referring to the 3rd line and 4th line, and there wasn't 3 and 4 lines there. And things I said about the 2nd line didn't refer to the 2nd line, but only part of the 1st line. It was just a disaster. I should have used a subequation environment so that it was explicit. I could label each component line a sub-expression as 5A, 5B, 5C, and 5B. And that would give them a hint to the layout editor. Leave this alone. So that's one example. What's the last thing to look at? Typesetting long mathematical expressions. It's an art too hard for computer recipes, where you put line breaks in a long expression. Too many possibilities. Depends what you as an author would want to highlight for the reader. What sort of structure is it? So we usually code line breaks by hand in the align environment. So typically what you do is you've got a long expression. I often get it from computer output, right? So I get computer output, plonk it into the text, and then say, okay, text source, where do I put the line breaks? The answer is usually you get that sort of code, and in the source, you just place that in. But there's no number, line break, a line, and then because it's not generally not an equal sign, it's in the middle of the expression, put a quad space to move the expression across so it's not immediately under the equal sign. Put a pair of braces so that the oncoming operator is a binary operator. Look closely, you'll see binary operators in LaTeX have more space around them. The unary plus or minus does not. So you need that pair of braces to do nothing except to say whatever follows is going to be a binary operator. Yeah, and then as I mentioned before, if the line break is inserted between a left and a right pair, then you need matching \right dots and \left dots. Begin this. Generally insert this sort of line, this sort of code on a line by itself so that you can easily move it around in the source code. Right, so that's what's generally done. That gets you the best results. You inputting the higher level decisions. The alternative, if you just want to be automatically flexible about multi-line presentation of long mathematical expressions, and you don't mind some crude typesetting, you can invoke Parbox. So one place where I do this is I run various web services that do computer algebra, and they output that computer algebra in LaTeX, which I then typeset for some user. Now, the thing is, I've got no idea how big those expressions are going to be, how many lines they're going to take. I don't know what sort of format, where good line breaks are going to be. So I need LaTeX to automatically put in line breaks. So that's why I use this trick of using a Parbox. And you can get expressions that look like this one being here. U1 is equal to some long expression, and it's automatically line break by in the maths, it's got different line breaks. There's the source code. This is an example from one of my web services with the interval thrown in just for fun. Okay, how do I typeset it without having to manually intervene? Via this command parm. Tell you about that. It uses Parbox. Right, so parmath has got one argument, which is the mathematics to typeset. So there it is, or part of it for this expression. And we say form a Parbox, align to the top of the Parbox, make the Parbox 0.8 of the text width, and change that if you need to. And then typeset the argument of the parmath, there it is, inside a maths environment, but typeset it ragged right, and with a mysterious line spread of 1.4 to get the vertical spacing better. And a mysterious select font I'm not going to say any more about. And it gives this sort of result. Right? If there's more space in the line, there are fewer lines. If there are longer expressions, you have more. Okay, so it's simple, it's crude, it's flexible. If you need it, you can do it, but yeah, it's not that. Now you might say, surely someone's written a package to do this. Right? Isn't that what I said about packages? If you want to do something, someone's written a package. The answer is yes, there is a package, the BR equation. Unfortunately, I tried it and a year or so ago, and it just was not reliable enough for general use. Okay, so that's it for mathematical typesetting. It is an art. LaTeX helps, but there's still many decisions you have to make. Just ensure you don't muck up what LaTeX knows. Right, so that's the last in this series of talks. Good luck with all your LaTeX.